morning student. I am your teacher Miss Dimple Dave. We are continuing with the first chapter of chemistry, matter in our surrounding. Earlier we have seen that what is matter, what is it made up of, and what are the characteristics of the particles. Today, on the basis of the arrangement of the particles, we are going to discuss different states of matter. Basically, we are having three states of matter, and one by one we will discuss the characteristics of all that, and we will write down that characteristics on the board. That you can say as your concept board and the technique for learning the topics. I am not going to write all that things in the full sentences, but just learn that how we can note down that point wise and how you can remember that for the examinations point of view. Now just have a look on these things which is in my hand. I am having a ball, I am having a matchbox, and I am having marker. What you can say about these things, this matter? You can say that they are having the fixed shape. Do you have the fixed volume? Yes. These objects do not change its volume. So regarding volume, we can say that this substances, this matter is having the fixed shape as well as the fixed volume. Say for example matchbox. So if I want to find out the volume of this, we are having the formula length, breadth and height. So L into B into H will give me the volume of this. Likewise for the sphere, 4 by 3 pi r cube is the volume of this. Yes, I remember that we are not discussing mathematics, but remember that science, especially physics and chemistry, are using the mathematical formulas many a times. So please go through that also, so the concepts will be very much clear. So as I said just now, the first characteristic that this matter is having fixed volume and fixed shape. Second thing, rigidity. We had discussed if I want to apply force, I am applying force just now. Is it compressed? Does it change its shape? No. These objects are rigid. In other words, I can say that these are not fluid compared to the liquid. We will discuss that in the next part. Then one more thing I would like to perform for all of you. This is a container, it's a ball, and I was having the matchbox also. Do these objects completely fill the container? I mean to say, I am putting this in the container. Does it fill completely? No. I am putting this another matter. Does it fill completely, fully? Answer is no. So these characteristics we had observed physically. On which basis these objects are having these characteristics? So fundamental three things are there. First, intermolecular space. Second, intermolecular force. And the third one, that is kinetic energy. Based on all these three characteristics, the rest of the characteristics we have discussed. Still there are many more, that diffusion, density, fluidity, compressibility. So few of them we are going to write down over here with the experiment. Just now we have seen for the solid. Why that substances were having fixed shape, fixed volume. So for understanding these three states of matter, you can take the help of the fingers for visualizing that. I had told you in the lectures that you can imagine yourself as particle. So you can imagine, as I had told you, that on a one bench 4 students are sitting. Then second situation, on one bench only 2 students are sitting. And the last situation, in 2 benches only 1 student. Try to imagine, otherwise we are performing with our fingers. Say just now my fingers are like this, right? How much space could you see in between? Very less. The space between the fingers are very less. So how will be the force? The force between the particles, individual finger you have to imagine as particle. So the force between the particles is maximum. Third thing, kinetic energy. What you can say about this particles' kinetic energy? Can they move easily? If this particle want to move very easily, is it possible? No. These particles can vibrate only at its position. They are not able to leave their position without any external energy. So, the kinetic energy of the particles of the solids are least. So, now we are noting down all these characteristics for the solid state. First of all, I am writing the characteristics and then I will write it for the solid. First, intermolecular space. Second, intermolecular force. Then, what I said, do you remember? It's kinetic energy. Kinetic energy is the energy related with the particles when they are in motion. Then we had discussed the shape and volume. Then we have discussed rigidity or fluidity. Then compressibility. Then fusion. And last one we are writing as density, but still the list goes on. So, as I told that these are the characteristics which we are going to discuss for all the 3 states. And one by one, first we have seen for the solid, now all that properties we are noting down. Then we will see the properties of the liquids and finally we will note it down for that also. So try to remember the things like that, and everybody is having their own technique for remembering. So just now first note down the characteristic, then write down the state of matter. What was that? It was solid state. Now for writing the particular properties, as I told you can write down that in words also. And somewhere you can use the symbols true or false, right or wrong. For example, intermolecular space. What did we see? It was large, very large, or least. What was that? It was least. Intermolecular space was least, very less. How to remember this? So you can remember one picture in which you can remember that arrangement of the particles are like this, as I had shown you with my fingers. So this is solid state arrangement. As the intermolecular space is very less, how will be the force? It is highest or it is maximum. Then kinetic energy, that is also very less, or we can say that least energy. Shape and volume, how it was? It remains fixed. Then rigidity or fluidity, the solids were rigid. Then compressibility. Do you remember the ball which I had applied force? Does it change its shape? No. So for compressibility, as I said, either you can write in words that it is not compressible, or you can just put cross. Diffusion, that is also not possible in solids. In the last lecture, we have discussed the definition of diffusion, that is intermixing of particles on their own. If I am having this marker and again I am having this one bottle, will it mix on their own? No. So, solid do not diffuse. Then density of the solids are maximum. At the end of this discussion, I would like to give one question for thinking. Can you see what is in my hand? I am having rubber band. The characteristic of rubber band, it's elastic. So we have written, okay, is it solid, liquid or gas? Yes, it is in the solid form. But we have written for solids, it is having fixed shape. I am applying force. Does it change its shape? Why it happens? Think and let me know what did you find for this. Now the characteristics we have listed for solid state. The second state of matter, that is liquid. Now we are talking about the characteristics of the liquid state of matter. Very common example, we are having water. Just now I am having plain water with me. Does it have fixed shape or fixed volume? So you can see the shape of this container. You can see the shape of this container. What will happen if I am putting this water in this? Does the shape remain the same? No. The shape of this water is different because of this container, and in this the water has taken the cylindrical shape because of this container. But what about volume? So these are the measuring cylinders or measuring containers. So you can see whenever you are getting the time, I will take you to the lab, that small markings are done on this. You can have the mixture jars nowadays, transparent jars, which are also having this marking scaling on it, where you will find 250 ml, 500 ml like that. Just try it at home. If you will take 100 ml or 250 ml. In any of the container, when you will pour this water, it will change the shape, but 250 ml will remain 250 ml only. So first characteristic, liquid is not having the fixed shape, but it has fixed volume. Can we compress it? Negligibly. The answer is negligibly, or we cannot compress. If I will try to apply force on this water will come out. Doesn't mean that I had compressed that. So negligibly compressed. Fluidity. You have seen just now that if I am pouring this into this, does it flow? Yes, water can flow. Then what about the diffusion? Intermixing of the particles. Earlier also we have seen one activity similar to that. One more activity. I am having plain water. I am having red ink. I am just pouring. What will happen if we are shaking this? So these particles will mix with the water, and somewhere if they are not able to mix, so which characteristic? Density of the ink. The density of the ink is not allowing to mix it completely. Petrol, kerosene, you may try at home that if we are having that and if we are trying to put it in water, so layer of kerosene will be formed on the water. But diffusion, that means the particles are intermixing on their own if the density is less than water. Why it happens? Why these characteristics different than solid? So once again the answer is the arrangement of the particles, or we can say the intermolecular space between the particles. Once again, let us take the help of the fingers. In solid state, I told you that fingers are the molecules and that molecules are arranged in this way. But what happens in liquid? In liquid, the particles are having less intermolecular force, larger space compared to solid. Just try to understand, this is solid state and this is the liquid state. So the gap between the molecules, you can see that particles are having larger or more intermolecular space. As a result, the force between them comparatively less than the solid state. Kinetic energy, these particles can move comparatively faster, and because of that the diffusion means intermixing of other particles in between. We have discussed the example in the starting that if I am having this plain water and I am adding lemon juice, or I am adding the crystals of this salt, what will happen? It will mix with that. So what happens that the particles of water are having this much intermolecular space. In this space, the particles of lemon juice or salt or sugar are adjusted. So we can say, we can list out the properties like this: intermolecular space larger. The picture for that you can remember that compared to solid, it is like this. So you can see the difference between intermolecular space of the particles. As a result, force will be less. Then kinetic energy, that will be compared to solid, it will be more. See, as I told that I am writing the keywords over here. In the examination, if this question is asked in 4 marks, you are supposed to write down the full sentences based on this. Try to write it grammatically proper, but keywords are the words which can give you the full marks. So, these words must be added at proper place, right? Then kinetic energy, after that we are having shape and volume. So, liquids do not have fixed shape, but volume is fixed. Then what we can say about compressibility? It's negligible. Does it flow? Fluidity? Yes, it is fluid. Then diffusion? Yes, diffusion fast. Density? Medium, moderate, any of the word you can use for that. So, this is the properties of the liquid we have listed. Now, the last third state of the matter, that is gaseous matter. What do you find in this? Can you see anything? We are saying no. But if I will put a lid on this, and after that if I will try to dip this in water, I can see the bubbles in the bucket of water. Then we are having empty bottles with closed lid. What does it contain? It is having air inside that. Then what about the compressibility? Can we compress it? So you are knowing that plastic bottles, empty bottles, we can crush very easily. Just now also I am applying force and this is getting little bit changing its shape. Doesn't mean just now it is open, so the effect is less. Then after the compressibility, does it fill the container completely? So we have seen solid, we have seen the liquid. This liquid does not fill the container completely. You can see the empty space. But what about the air or the gaseous state? So gaseous state, gas is completely filling the container. How to believe? I am not able to show you the air just now. So you can have that old activity of the incense stick. Whenever we are lighting the incense stick, so the smell of that reaches from one corner to the another corner. Same way you can take the example of perfume bottle. Whenever we are opening the perfume bottle, the smell, the aroma, the fragrance is spread in all over the room. That means the gaseous state is completely filling the container. Then we are having one in-text question in our textbook. Does the gas pressurizes the wall of container? Does it give pressure to the container's wall? Can you think? Yes, the answer is correct, that gaseous state, air, smoke, fog, all these things are giving continuous pressure on the walls of the container because their kinetic energy is highest. And as we were discussing with the examples of finger, so solid state, liquid state, and now this gaseous state. So you can see the space between them, and you can see that how fast this can move. So gaseous state is having least space, least force. Am I right? No. The gaseous state is having largest intermolecular space, and as a result the force is very less. Kinetic energy is highest, particles can move very fast, and based on this the rest of the properties we are listing very fast. Gaseous third state of matter, intermolecular space very large, and the picture for this you can remember like this. Just compare these three. Then intermolecular force, that will be very less. Even you can write least also. Remember the spell of least over here. Kinetic energy, that is maximum. After that, shape and volume, no fixed shape, no fixed volume. So you can just put the cross. At the time of examination you have to mention it properly. Rigidity or fluidity. So air can also flow. So the fluidity or the word fluid is used commonly for liquid and gas. These both are commonly said as fluid, right? Liquid as well as gas, they both can flow. After that, compressibility, we had taken the example of filling the air in bicycle tire. So compressibility, that is maximum. Just now you can put the right tick also that it is compressible. Diffusion, very fast. Diffusion is very fast. And finally density, that is very less. We are feeling it very light. So here we are coming to the end of the topic states of matter, physical states of matter. 3 states are there. Later on you will learn two more states of matter, but that is afterwards plasma and Bose-Einstein. Based on this, very few short questions can also be asked that justify the fan is solid. How can we write the answer? That's right. We can write down the characteristics of the solid. Fan is having fixed shape, fixed volume, it is rigid, it is not compressed, density of that is very high, and it will not diffuse. So on the basis of the characteristics, we can say that fan is a solid. Then which characteristics are common, which characteristics are not similar? This kind of questions could be asked to you from this part. Okay friends, after discussing the states of matter, our next topic is, can matter change its state? What do you understand by change of state? You can have two words for that: transformation, or we can say that conversion. Just think on this, that how many examples you are finding around it and which factors are responsible for that. I am giving you two factors also, and you have to think on that. The factors are, first, temperature. And second factor, you have to think about pressure. So these three states of matter which we have discussed just now, solid, liquid and gas. If we are increasing the temperature, what will happen? If we are increasing the pressure, what will happen? And I will give you one small common example, the favorite example compound that we are having, that is water. If I am having a water full of container full of water, if I am keeping that in freezer for 1 hour, this water will change its state. Think, if I am having bowl of water and I am putting that on stove, I am giving them heat. That means I am increasing the temperature. Will it remain water? No. It will convert into steam or vapor. So why it happens? What is the science behind this? And few terms related with this we will discuss in the topic, can matter change its state? That we will discuss in our next portion. Thank you.